The basis of everything we do in Algebra 2 is a function. You have to understand what a function means. You have to know all the parts. You have to know all the different functions and their parents. Functions is everything in Algebra 2. So we're going to do a little review of functions. This is Mrs. Field's favorite snack machine. It's got all the things in it that she's not supposed to have. So if you press a button on this snack machine, one treat will come out. If I press a button and two come out, the machine is broken. It's your lucky day, but the machine is broken. That's exactly like a function. If you press one button, only one thing can come out. That is a function. So we're going to think about functions as snack machines. So let's remember how to map. You should already know how to map. These are my things my buttons I can push, and these are the treats that can come out. We're going to go back to vocabulary and remember that we call these input and we call these output. Again, nothing radical here. Input is the button I push, A2, and output are the corn chips. That's what I got. But we need to know all the vocabulary. Now we've used X and Y values. You've used those a lot, but we really don't need those unless we are graphing. You're going to call it input or output or some other names rather than X values and Y values. The big, most important words that you're going to use are domain and range. Domain is what you put into a function, and range is what you get out of a function. And those we will be doing until the very end of the year, domain and range. Now there's one other thought you need to remember. I know this has been, you've beat it to death in Algebra 1, but let's remember independent and dependent. I can choose any one of these buttons I want. I can choose A2, B5. I can choose any one of them I want. I'm independent in how I choose them. But once I do choose them, if I choose A2, it has to give me corn chips. That means the corn chips is dependent on which button I push. So have we got all our vocabulary back in our head? So, what is the definition of a function? Well, you've had this one for a long time. An input results in only one output. And that's a perfect way of saying it, but I want you to make sure you understand. It's a lot like that snack machine. If I press a button, only one thing should come out. So let's try a few. Here's a map of a function. There's our relationships. Our input is A2, B5, C4. Our output is corn chips, Twinkies, and donuts. Is it a function? Yes, because if I press A2, only one treat comes out. If I press B5, only one treat comes out. Remember the snack machine. This is actually a special one called a one-to-one relationship. It's a one-to-one function. All right, let's look at this one. Is it a function? Yes. Let's go back to our snack machine because for a moment there you might have thought it wasn't, but it is. If we press A2, what came out? Corn chips. Just one. If we press B5, corn chips came out. Just one. This is still a function because only one treat came out with each button. So let's look at another map, and here are relationships. Is it a function? No. Let's look at this button right here. If you press A2, what comes out of my machine? Corn chips and Twinkies. The machine is broken. Two things came out. Use the snack machine analogy. It will help you a lot. All right, let's do a little bit more on relations. we're canoeing down the river, and for every second that we are canoeing, we are moving 3 feet. So at the end of 1 second, we're 3 feet from where we started. At the end of 2 seconds, we're 6 feet. This is a map. Is it a function? Yeah. Let's use this one to think about this. If I had my input was at 1 second, the boat was both 3 feet and 9 feet. Is that possible? Can a boat be in 2 places at once? No. Think through what's really happening. Don't try to just memorize, well, if it doesn't duplicate, or don't stop that. Use your thinking. That's what we want to do. Critical thinking. All right. Let's review set notation. Okay, we have a relationship, and we have input, and we have output, and if we wanted to do the set notation, we would take the input and then the output and make it a coordinate pair. Input and output coordinate pair. Input and output coordinate pair. This is the set notation for the same data that you've been mapping. All right, how does this look in Algebra 2? Well, Algebra 2 is going to be a little harder. It's going to give you a function. It's going to say f of x equals 2x. Well, I've picked some numbers over here. Can I pick any numbers I want? Yep. So I picked some numbers over here, and I plug them into the formula to get my output. So if I put negative 2 in, negative 2 times 2 is negative 4. If I put negative 1 in, negative 1 times 2 is negative 2. And I build my output. And that's something we're also going to have to do. Now, we're going to go ahead and start inverses. We are going to deal in so many types and ways of doing inverses, so we might as well start right now with the basic idea. And the basic idea is you switch domain and range. That's what you do. What is inverse? Inverse is switching the domain and range. So let's have a function. We've got this nifty function right here. It has 1, 2, 3, and 4 as the input. It has 1, 4, 9, 16 as the output. You can probably guess it's probably an x squared, but that's the function. Now, this is the symbol for inverse of the function. See the little negative 1? So that says that I'm going to take this function and I'm going to invert it. Okay? So here's my 2 circles. Now what do you think should be placed in the first circle? Well, remember again, what are we doing? Switch domain and range. So this time, 1, 4, 9, and 16 are going in the first circle, and 1, 2, 3, and 4 are going in the second circle. And of course, we always have to evaluate whether it is a function. Now, the original was a function. It was a one-to-one function, wasn't it? The inverse is still a function. It's still a one-to-one. Let's try another one. Here's our function. 1, 2, 3, 4, 6, and 7. If we want to find the inverse, what goes in the first circle? Well, the first circle is going to be 6 and 7. The second circle, 1, 2, 3, and 4, because we switch domain and range. Let's put our relationships back. 1 and 6 were a relationship. 6 and 2 were a relationship. 7 and 3, 7 and 4. Now let's evaluate. If we look at the first relationship, the light blue relationship, is it a function? Yes. If I push 1, a 6 comes out. If I press 2, a 6 comes out. But over here, is the inverse still a function? If I press 6, what happens? 2 treats come out. A 1 comes out and a 2 comes out. So since I press 1 button and 2 things come out, it is not a function. This was a function, but that was not. All right. You have some practice problems on your note page. You need to fill out your note page, do your practice problems. And as Commander Taggart would say, never give up, never surrender.